Thank you so much for having me here today. Kind of weird to be giving a talk in English at a Spanish-speaking conference, but in Argentina it's super cool. I'm super excited. Let's get right into talking about server-side WebAssembly. And this is quite a bombastic title, isn't it? The post-container revolution is here. And I'm going to be real with you all, friends. We're going to have to put an asterisk here. Like, we're not quite post-container, so there's one. Actually, okay, no, there's two. Um, there's two title asterisks here, and we'll get into why. But before we get started, let's talk a little bit about server-side. Let's talk a little bit about, can I get a couple of virtual hands up? Containers, how do we feel about those? We cool? These compartmentalized runtimes that let us run, for example, an image of an operating system, or chunks of an operating system. Have we heard of WebAssembly yet? If not, don't worry. We're going to cover all of this today. One more. Have we heard of me? Hi. My name's Ramón. My pronouns are he, him. I'm originally from Chile. I've been living in Austria for a very, very long time. I'm a co-founder of the Bad Website Club, and I mostly specialize in developer relations strategy consulting. But education is a large part of that for me. I just love being able to impart knowledge and share with communities and learn from communities, which is why I'm so excited to be a part of this conference. Thanks again for having me. So yeah, in this talk, we're going to learn all about WebAssembly and why its future on the server is so exciting. And in order to do that, we're just going to have a conversation with a couple of questions. Those questions are what, why, how, when, and where. And trust me, these will make sense. So let's start with the what. What is WebAssembly, or as it's commonly known, WASM? So taken directly from the website, WebAssembly, which is abbreviated as WASM, is a binary instruction format for stack-based virtual machines. WASM is designed as a portable compilation target for programming languages, enabling the deployment on the web for client and server applications. And this is quite a very straight to the point definition. What we're talking about here is a way for us to compile our code or translate our code down to a level that can be used in the web, hence the name WebAssembly. It's assembly-like. But a couple things I want to clarify. First of all, if you've thought this, don't worry, I've thought it too. WebAssembly is not a programming language. When looking into WebAssembly, you might also think, hey, I want to learn WebAssembly, I want to check it out. But here's the other thing. WebAssembly is also not kind of like a front-end framework. It's not something that you use in the browser to run your apps, kind of. What it is, it's an established standard for low-level bytecode. And when we think of bytecode, we've heard of this before on low-level, the assembly that runs on our computers or our devices on a daily basis. This is a standard that is made for the web for bytecode. So your code will translate to this bytecode. It's a compilation target, kind of like how you would compile a certain kind of Mac. You've got the M1, the ARM, and the Intel Macs. You've got your Windows 32-bit, 64-bit. These are compilation targets. WebAssembly, likewise, is a compilation target for your code so that it can run on the web. And WebAssembly was originally envisioned as a way to run your code in a browser. And it was done in a way that did so with like low-level JavaScript. And it allowed for some pretty cool things. For example, if you're all familiar with the archive.org website, which allows you to check out old software, it also allows you to run it. That means that you can run old games from the DOS era, games that I grew up with, like Prince of Persia, running natively in your browser through DOSBox, which runs on WebAssembly. Now, word to the wise. If you're ever researching a talk for WebAssembly and you're like, hey, cool, I'll check this out, be very, very careful with your time because you will get stuck playing Prince of Persia for a very long time. It is a very good game. But it's not just for games, it's not just for old software, it's also for current standards. Let's look at, for example, Squoosh.app, which is a project to allow you to run complex image transformation or formatting algorithms in your browser. And you're probably thinking like, well, I could do this with JavaScript, right? And I'm like, yeah, sure. But the thing is that what makes it so possible and so cool, you can see that we can like drag and drop this image format, this image compression on this image of a red panda. What makes this possible is that both that JavaScript is not quite the ideal language for, say, image compression, but you can port, that is, compile existing code from your existing compression algorithm, say, written in C, and not having to rewrite it in a less down bare metal language, in a closer to the metal language like C. But it also lets you run pretty complex and pretty big software. What you're looking at here is StackBlitz, who are a group of folks that figured out how to run Node.js in your browser. And yeah, that is what I mean. I don't mean like emulating. I don't mean like, a cloud instance. I mean like Node.js and the system interface it has running in your browser. How cool is that? And hey, I said small software. I said big browser. How about existing really huge software? Here is LibreOffice running in a browser. You heard me right. All of LibreOffice, which is like an open source alternative to common Office utilities, running existing code base in your browser through WebAssembly. Of course, you do have to like download 300 megabytes of binary code, but hey, it works. And sure, you might say, cool, but like Ramon, you're talking about the browser side. Your title is about server-side WebAssembly. Surely WebAssembly can't just run anywhere. And in a way, that's true, because bytecode will only take you so far. But that, my friends, is where WASI comes in, which is short for WebAssembly, now with a system interface. What is a system interface? For that, I'm going to... Oh, goodness gracious. If y'all haven't seen Lynn Clark's guide to WebAssembly, I'm going to put some links in this presentation. These are incredible ways of explaining and making it more approachable for someone like me who spent most of their time working with like, Mac apps and like web development, not really doing much with like low level, bytecode stuff, making this approachable. But anyway, I digress. Applications don't actually have direct access to operating system resources such as file systems and networks and that sort of thing. What they do is communicate through a kernel, which is a kernel, or as the name implies, the core of an operating system that allows applications to be like, hey, you want this file? Don't worry, I'm going to go get it, and gives it. This is called an interface, a system interface, if you will. And so WebAssembly, WASI, is the WebAssembly way of having these system calls. And this is just a standard that folks are using. Now, bear in mind, just to be clear, this does not mean that WebAssembly replaces an operating system. You still have to, implement that operating system. Let me let the folks from Wasmtime try to define it a lot better than I would. It's an API designed by the Wasmtime project that provides access to several operating system-like features, including files and file systems, sockets, clocks, random numbers, and so on and so forth. So let's think about how it is that we package up our code. We take a program written in C, usually using a program called clang or clang to compile it, and we give it a format and target to turn it into an executable file. For example, the format in Linux is going to be ELF, in Windows is going to be portable executable, in macOS it's going to be called Macho or Maco. Now, cool, but what about WebAssembly? With WebAssembly, what we're doing is compiling our C code to the WebAssembly standard. And then on each of Linux, Windows, and macOS, we have what's called a WebAssembly runtime that reads that bytecode and executes it. So it's kind of a closer to low-level way of doing this. What's cool is that not only do we have a single code base, we also have a single binary format, or a bytecode format, which is quite cool. But what is a WebAssembly runtime? And I kind of mentioned one when they were defining WASI. One is Wasmtime, which is a project that is meant to run WebAssembly code here, and very specifically here, outside of the web. can be used, for example, as a command line utility or as a library embedded in a larger application. And the point is that it's meant to implement a lot of these system interfaces so that we can then run this WebAssembly code wherever we like. And there's lots. There's WASM3 is also a WebAssembly interpreter. WAS0 for Go developers. WASME for doing your very small smart contracty things. We'll get into more of that a little bit more later. There's WASMer. But hey, cool, we have WASI on the server. Let's talk about the browser for a second again. There is a polyfill for running WASI in the browser. So yeah, it's meant to have that compatibility that runs pretty much everywhere. I've mentioned mostly operating system. You might be wondering, but does that include the cloud? And there are specific runtimes such as WASM Edge for running your WebAssembly in edge computers in the cloud. And that could be even in a container. Get more into that in a second. Here's some further reading. I said I'll post out these resources on socials as well. Definitely check out Lynn Clark's guide. So good. Cool. So we've answered what is WASM. Now we're going to answer the question, why run WASM on the server? And hey, don't take it from me. And if you've done stuff with WebAssembly on the server before, this tweet I'm about to show you is going to seem pretty familiar. From Solomon Hikes back in 2019, who's saying, if WASM and WASI, remember, WebAssembly and the WebAssembly system interface existed in 2008, we wouldn't have needed to create Docker. That's how important it is. WebAssembly on the server is the future of computing. A standardized system interface was the missing link. Let's hope that WASI is up to the task. And what are some advantages that WASI brings over, say, running an entire an image or a container on your server? First of all, WASI and WASM is designed with capability-based security. Quite fancy. What does that mean? It means that every access you want to give to a WebAssembly module needs to be declared on startup. It's an opt-in. Yes, it's an opt-in security measure. That means that you run something, it's not going to immediately have access to everything. From the start, a program needs to say to the system interface, hey, I'd love access to this file. This helps you avoid things like supply chain security and vulnerabilities. It allows you to have your programs run in a sandbox. And being a bytecode target, it's polyglot by nature. You can write your code in any programming language you like. Because it's used in a way that's meant to be ephemeral, that is, use it once, throw it away, it means that the modules that you run in these runtimes are typed, small, and provisionable. What does that mean? It means that they are scalable. It means they are pre-optimized. That means they don't have a state. More on that later. But it also means that because it's bytecode and near native speeds, it is tremendously fast. There's no container startup, there's no VM startup, you're just off to the races. This has a huge impact on speed. If you're interested, check out this talk from Luke Wagner from Cloud Native WASM Day last year, who talks about putting WASM in production. And as he puts it, serverless execution. It's ultra fast, it's got a cold start, it's ephemeral. You spin something up, you run it, you throw it away. Keeping state is not needed. You just have a module whose sole purpose is to do a thing, do it once or do it several times, and kind of eliminates the problem of have you tried turning it off and on again. So really, if you think of this diagram from Lynn Clark, you've got your Linux, you've got your Windows, you've got your Mac. I'm going to try, okay, I have to admit, I'm not a very good artist, so I apologize. I didn't want to doodle on top of Lynn's incredible work, so instead, I made my own. I'm sorry, it's not very good. But you've got your C code, it compiles to WASM, you run it in a runtime, and it runs on the cloud. Your code attaches to these system resources right as it's starting. And this is achieved, by the way, as said, with WebAssembly, System Interface, or WASI. But cool, what does this mean for our industry? What does it mean for us as DevOps or software developers? It means that we can write code without ever having to worry again about server setup, It's just there. You don't have to worry about like installing something or other. You're just like, hey, run my code, please. It means we can write code without having to worry about startup and shutdown times. These are modules. They're cold starts. They're ephemeral. Boom, done. All it goes. And that affects scaling as well. As I said, you can spin up a bunch of these little modules. And we don't have to worry about common security issues anymore. So that's the why. Here's some more reading. Highly recommend checking it out. Cool. That's what, that's why. Now let's talk about how. How is WebAssembly currently being used on the server? And some applications you might have already thought of, but there's some I bet you haven't. For example, let's talk about functions as a service, kind of like a serverless kind of thing that are provided by companies like Dino, Second State, Cloudflare, and Fastly, allowing you to give your users the ability to just quickly write a quick function and just have it do its thing. This also goes into edge computing or microservices. You've got folks like Wasm Cloud, Fermyon, Cloud Native Computing Foundation, and Vercel offering these services to their users to have these just little edge computing abilities to run codes on the edge that is closer to your end user. There's also the factor of extensibility. Figma, Istio, and Shopify are providing ways so that you can provide your users the ability to write code that runs against your software as a service platform without having to worry about security, scalability, all of that. I think it's pretty cool. Big caveat coming up. I do not know anything about Web3 or blockchain or any of that stuff, but folks like Parity are using are running their smart contracts, which are these little pieces of code on blocks when they're chained. Sorry, I'm very not knowledgeable on blockchain, but you've got these small ephemeral pieces of code that are executed on transactions in a inherently distributed. I cannot talk today. I'm sorry. In an inherently distributed platform. Having the security to guarantee that these smart contracts, these little pieces of code, are cross-platform, that they're secure, this WebAssembly is a perfect fit for this. And hey, how about embedded? Folks like Acri have tools to be able to run WebAssembly in your embedded devices, which I think is incredible. So that's the how. Here's some more resources. I said I'm going to post these slides out as well. Cool, so that's the what, the why, and the how. Now for the when. When can we replace our containers with WebAssembly? Again, don't take it from me. Take it from Solomon, who followed up on that tweet I showed you earlier with this one. Quote, so will Wasm replace Docker, unquote? No, but imagine a future where Docker runs Linux containers, Windows containers, and Wasm containers side by side. Over time, Wasm might become the most popular container type. Docker will love them all equally and run it all. Now, I don't want to spoil too much about this talk, but keep an eye on that timestamp. That was tweeted on the 28th of March, 2019. For more than 4 years ago. Just saying. But to Solomon's point, not only just like containers didn't replace virtual machines wholesale and only replaced virtual machines where virtual machines were used, but perhaps not ideal, so too will WebAssembly not replace containers wholesale. They'll only replace containers where containers are used, but not ideal. And we're already starting to see this happen. Crosslet, for example, is a project that allows you to run your WebAssembly workloads in your Kubernetes cluster. That is, your distributed set of services in your complex topologies. Heck, it's not even just running modules. It also having programming languages that are built from the ground up to be compiled to WebAssembly. That's Grain. It's a programming language that compiles directly and is built from the ground up with WebAssembly in mind. But that's the current state. There's still more coming. For example, the folks who are the committee and the folks who are working on the WebAssembly and the WASI standard are currently drafting things like a component model, making it easier for different WebAssembly modules to interact with one another in a more seamless and out-tradable, like trading them in and out fashion. There's also a WASI-NN, or neural network standard, for doing your machine learning stuff in WebAssembly. They're also getting garbage collection going. There's no garbage collection right now, but they're working on a standard for it. They're even getting multi-threading going for WebAssembly. Now, I said this is still all in the works. Remember what I mentioned about Docker and WebAssembly? And by me, I mean Solomon in the tweet. Guess what? Last year, Docker announced a Docker plus WebAssembly beta. That was 3 years after that tweet was made. What does that mean? It means that just as you have your containers for other operating systems or runtimes, now you can run your WASM modules in a Docker engine. Now, bear in mind, beta, standards being agreed upon, yeah, a lot of this is new, a lot of this is work in progress, but I wanted to show you how exciting the future looks for us. So to find out more about that, here's some more further reading and watching. All right, so cool, we've done the what, the why, the how, and the when. Last question is where? Where can I see and follow what folks are collaborating on or working on WebAssembly? And I wanted to highlight a couple places for that. First, there's the WASM Builders community, which is a what are those called? I forgot the name. One of those Dev2 that runs on forum, a forum instance for WebAssembly enthusiasts. There's the Bytecode Alliance, which is an alliance of several companies. You can see them here. You got folks like Amazon, ARM, Fastly, Google, Shopify, Suborbital, Intel, Siemens, StackBlitz, VMware. That's only the ones that I quickly did not read in Mozilla. Okay, I wanted to shout out Mozilla. That are working on and collaborating on the future of WebAssembly. And you can even follow up yourself. They've got a community group. They've got events and reports on things that they do. Also highly recommend checking out the GitHub WebAssembly organization. So that's where you can go and follow up on this stuff. All right, friends. It looks like we've covered a lot, and we kind of did, didn't we? We've learned what WebAssembly is, why WebAssembly is great for the server, how folks are using WebAssembly in production, when it'll get more widely adopted, or how that roadmap looks, and finally, where folks are going to collaborate on it. And I said, I've shared a ton here. Just want to share the link to these slides. That's ramonh.dev/server-side-wasm.pdf. And that's me. Have a wonderful rest of your conference at Nerdearla, and it was great seeing y'all. Take care now.
Vamos a nerdear.
Bueno, buenísima la charla de Ramón, espectacular. Ahí todo el mundo elogiando la pronunciación de Ramón. Y lo tenemos a Ramón conectado en línea, ¿no? Hola Ramón, ¿cómo estás?
Hola, hola a todos. Yo muy bien, muchas gracias. ¿Cómo están ustedes?
Muy bien, muy contento de tenerte. Aprovechando que sos un amigo latinoamericano, vamos a hablar en nuestro idioma nativo. Así nuestra audiencia no tiene que andar haciendo el esfuerzo, aunque muchos han escrito las preguntas ya en inglés. Vamos a hacer el esfuerzo yo de traducirlo, aunque no soy traductor. Así que, buenísimo.
Perfecto.
Si querés, empezamos directamente con las preguntas.
Dale.
Buenísimo. Acá nos pregunta Santiago cómo WASI afecta a los usuarios con una conexión de internet relativamente lenta, ¿no? Cosa que es frecuente en los países del subdesarrollo. Si es que afecta.
Sí, es una buena pregunta. Es una buena pregunta. Yo creo que el lío en eso es que el WASI lo que es más que nada una interfaz entre un módulo de WebAssembly y el contenedor o la máquina virtual. Entonces, yo no creo que WASI en sí vaya a afectar eso. Sin embargo, ya que los programas que se pueden desarrollar para que puedan andar con WASI tengan esas más capacidades, incluso puede que permitan tener, especialmente en lugares con conexiones más inestables, como la que tengo aquí, tener más habilidades que se hagan en el servidor en vez del cliente. O sea, por ejemplo, tener estos módulos que anden, que comiencen con más rapidez, que se puedan echar a andar y apagar con más rapidez y flexibilidad, se permitan tener de tal modo de que las conexiones realmente, especialmente a medida que vamos teniendo un mundo con más edge computing, que es de esperar que se vaya a desarrollar en lugares más escasos del mundo, yo creo que vamos a tener más capacidad de lo que teníamos antes. Espero que eso sea una buena respuesta.
Está bien, está bien, está bien. Hay que probar. Vamos a ver cómo termina funcionando, ¿no? Bueno,
Claro.
Jorge acá un amigo de la casa, Jorge Agreu, nos pregunta si vos ves que hay algún caso de uso en el que WASM pareciera tener la punta de lanza para el futuro, ¿no? Donde es sí o sí algo que deberíamos usar.
Sí, yo creo que estamos justo al tope de esto. O sea, mucho del contenido que estamos viendo hoy en día, claro, es justo como que el bleeding edge, como se dice en inglés. O sea, estamos recién viendo de qué es capaz hacer con WebAssembly, especialmente con WebAssembly en el servidor. Y tenemos la capacidad de tener programas que podamos echar a andar de una manera extremadamente rápida y eficaz, como dije antes, que se puedan desarrollar sin tener que preocuparse de cosas como la seguridad, de cosas como los recursos de servidores y esta clase de cosas, donde uno se ponga a pensar qué es lo que puedo hacer especialmente con estabilidad, o sea, con la flexibilidad de poder desarrollar software de una manera de que no se tenga uno que preocupar, tal como nos hemos movido varias veces de plataformas distintas, por ejemplo, de la máquina virtual al contenedor. Ahora estamos viendo algo muy similar del contenedor a módulos de WebAssembly. Y eso solamente se va haciendo más accesible, especialmente con los avances que estamos viendo ahora, como mencioné en la charla. Por ejemplo, este patrón de componente, el component model, que nos permite enlazar módulos de WebAssembly de tal modo que ahora puedan comunicarse y tener más flexibilidad y más posibilidades efímeras que nos permitan poder trabajar de un modo más eficaz.
Claro. Bien, ahí relacionado a esto también nos pregunta Jorge, y la gente va sumando su thumbs up para que hagamos la pregunta. En containers uno puede definir más o menos bien el contexto y extensión de a lo que se tiene acceso o a lo que el software tiene acceso y que corre ahí adentro. En WASM, un bug o error de seguridad en el código, ¿no se podría extender al servidor o al host que lo está ejecutando?
Sí, por supuesto. Y eso va a depender de nosotros como desarrolladores, tener ese capability-based model. O sea, permitirle las capacidades a un módulo de WebAssembly que el interfaz de sistema, el WASI, que nos obliga a decir, oiga, yo quiero hacer esto, esto y esto y esto. Y eso no se cambia hasta que ese proceso termine. Entonces, eso depende de uno como administrador o como DevOps, decir, bueno, este módulo de WebAssembly va a hacer esto, esto, esto y lo otro, y nada más. A mí lo que me ayudó a entender esto más es del mismo modo que uno mira las capacidades de un celular, por ejemplo, de una aplicación de celular, donde uno dice, ya, bueno, por ejemplo, esta aplicación puede hacer esto y esto y lo otro, tener este sandbox, que fuera de eso uno no puede salir. Pero el error humano también, también existe, ¿no?
También estamos, ¿no? Nosotros estamos acá para generar esos errores.
Sí, claro.
Bueno, digo, si tenés que recomendarnos algo cortito como para quienes quieren arrancar con WASM o WASI, ¿por dónde arrancamos?
Sí, mira, yo les puedo recomendar un par de cositas. Realmente les recomiendo mirar ciertos los ejemplos que estuve mostrando de la web, que realmente ayudan a entender de una manera instantánea de qué es lo que es capaz WebAssembly. O sea, de agarrar especialmente nuestro propio código. Si tenemos código que realmente no se había desarrollado originalmente para la web, echarlo a andar de tal manera de ver qué es lo que es posible con WebAssembly. Por ejemplo, en archive.org, donde tenemos los juegos de DOS, ¿ya? O los algoritmos de compresión de imagen, por ejemplo, que era código que existía hace décadas, poder echarlo a andar en un browser, ya es como una pista de lo que viene. Lo que yo recomendaría es jugar con los runtimes. O sea, por ejemplo, si uno agarra, por ejemplo, wasn't no sé, no sé si lo vieron y si no, creo que puse links ahí para los slides.
Sí.
Y si no, los voy a tuitear.
Sí.
Sí, ponerse a jugar con los runtimes y ver qué es lo que uno puede hacer. No sé si les puedo compartir un link aquí, ¿no? ¿Verdad?
Acá no, pero sí en el chat, así que después, de última, si no, lo compartimos
Lo voy a
nosotros.
poner.
Así que, bueno,
Perfecto.
Ramón, te agradecemos
Les tengo una
muchísimo.
tutorial. Ah, perdón.
No, eso, que te agradecemos muchísimo el tiempo, la conexión, la charla. Y nada, quédate acá conectado, que ahora lo que viene seguramente también te interesa. Y seguimos conectados en Nerdearla para seguir disfrutando de esta 10ª edición de esta gran conferencia. Muchas gracias, Ramón.
Felicidades y muchas gracias por tenerme.